Hello guys, welcome. On today's tutorial, I'll show you how I created this spinning animation of a coin and a base. Basically, it's using the same thing here, by the way. It's the same procedural setup. There is no keyframes here. It's all procedural done in the graph, in the Bifrost graph. And you will see that it's actually pretty straightforward. It's not very complicated, and it's a fun little setup that you can use on your own work. With that said, let's get started. Alright, so this is the graph. As you can see, it's nothing really super complicated or any kind of like a big graph. And basically, this is the same graph that I use for the coin and the base. The only really difference between these two is that the way that I created the strand, basically, which is basically the hero on this effect to make this work. And I'll show you how basically for the base I create the strand procedurally inside Bifrost, and then on the coin, basically I pick the edge loop, and then I went to modify, convert, polygon edge to curve. So let me hide the USD Stage. By the way, the USD Stage is also done in Bifrost, something very quickly that I did. I'll show you that at the end. Alright, so let's start here. Actually, let's start with Maya. So, and let's say that I have this asset, and let me hide all these nice little previews here for the viewport. Anyway, so you can do actually, by the way, the coin, the whole setup inside Bifrost procedurally. But most likely you're gonna be running this with your own assets that you either create in Maya in other DCCs, and you bring it the same with the base, by the way, right? So as you can see, the geometry is not very nice for the base, but it doesn't really matter because we need to just grab something. So let me start with the coin, and you can see I have a coin group here, a transform group, and I have a hierarchy. I have the geometry and the spline. So if I isolate that, you see the spline. And then we see the coin. The way that I created this, as I mentioned before, basically is just grabbing the loop. So let me hide that, and I just pick an edge. You want to actually pick this edge. You can see how the geometry is actually at the bottom here, at the origin, and basically the bottom is at 0, 0, right, on the grid. So if that wasn't the case, you will need to actually change this a little bit. But anyway, I'll pick it in the bottom. So if I grab an edge by double clicking, right, I have now the loop, as you can see, selected at the bottom. Then I can just do modify, again, convert polygon edge to curve. And that's, as you see, it's going to give me an edge, right, from the polygon itself. So that's what I did. Then I put it in a group here, in a transform group, and then basically to bring something to Bifrost, in case that you don't know, let me do it right here. If you try to bring the whole group, that's not gonna work. So what you need to do is basically bring either the geometry or any of the items that is inside this hierarchy, or the strand. I'm gonna bring both. I'm gonna explain something very quickly here. Let me hide this now. Let me draw a terminal here so we can see that we have the coin shape, and then also the strand. So if we look at the parameter window here, each element or each kind of like primitive that you bring here either will be like a strand or a geometry or a locator. It will have different options on this window. So for geometry, we have color set and component tags, meaning that you can, if you paint something with a match, painted vertex color, you can bring actually those color set into Bifrost and read them. You can bring all of them by default, or just specify which one you want to bring. You can also do component tags. In this case, we don't have any. So if I do Control A here, you can bring component tags from Maya into Bifrost as well. And then you can compute the normals and per point or or face vertex. If you will look now at the strand here, right? This has different options. We can compute the tangent of the strand or the length of the tang. We also can bring component tags from the strand itself, and how basically what kind of tag mode you want to use here, and then also how this is going to be sample. We have different options. Again, this is all in the documentation I can go over, but I don't want to make this video long, and I know that probably is going to be the case. But I want to try to make it as short as I can. And then the segmental multiplier basically is kind of like a resample strand, or which actually, if you didn't know, you can also resample the points of this strand after the fact, but you can also do it here. So if I drop a point scope real quickly here, and we look at this, so we can see the points now, and we are trying to preview a property, a color property, but we don't have any. Let me make this guy smaller. So now you can play with these values just to kind of resample this strand when you bring it. You can also just say basically evenly space these points when you resample. So those are the options. As I said, whatever you bring into Bifrost, whatever is supported, it's going to have different options. All right. So this is good and dandy, but sometimes it's good to bring this separate, but sometimes actually what I want to do in this case is just bring the whole hierarchy in it. So the way that you do that, and this is going to be important because I've seen a lot of people confused with this, is like looking at the ports. When you see a port, by the way, the blue color, I'm going to just talk about this very quickly. Blue color means objects. It can be points, it can be strands, can be volumes, can be meshes, it can be anything. So that is an object in Bifrost. It's just an object type. And then if we look at different data type, like for example these guys, which are like this kind of darker green, that means a float. The lighter greens is a vector, and then you have this kind of like yellowish kind of look is a string. The orange is a boolean. So you can just look at when you get used to, like for example here there is an integer or a long. When you start looking at the colors, you can see what kind of data type it is expect. The ports means, for example, you have auto ports, you have auto looping, you have objects, one object, or you have arrays. So right now we're reading one object, right? The coin shape, and you don't see the shape because I have shapes hidden. But if you look here, that is actually the object, right? Like the shape of the object. So it brings everything. The same with the strand. But let's say that I want to bring now the whole hierarchy. What you can do is actually use another slash here, so a slash, and then use a wildcard. So that's saying, okay, grab everything that is inside here. And as you can see, hopefully you notice here, that this changed from a square to this kind of hat icon. And that means that now we are dealing with an array, meaning that is a list of objects in this case, because we are dealing with objects. But arrays can be anything. Can be a list of floats, can be a list of vectors, can be a list of booleans, integer, objects, volumes, you name it, right? So just a list of things. If we press W just to do the watch point, you can see that the size is 2 because we have 2 objects here, right? If we add more objects into this hierarchy, this can increase. Since we have just 2 objects, that's the size. Now, if you want to see, you can see this like for a quick preview here. But let's say that you want to, if I press actually W here in the strand, which is one object, it's going to show me actually the attributes of this. And also it's going to show you like the quick data, like for example, how many points this strand has. That is how many strands or splines, just we have one with that many points. And then you can see that this is actually a float 3, the point position ratio is a float, strand offset is a unit, a U unit, and also it's going to tell you the target of these properties, right? But that is a quick view. You cannot see, for example, if I wanted to see like the per point positions, the watch point is not going to allow you to do that. So if I wanted to do that, you can actually look at in the data browser. And as you can see, we have 2 things here because arrays start from 0, by the way. So 0, 1, 2, 3, and so forth and so on. So in the first one, we have the object, which is actually the polygon, because I can tell by just looking at the data here. And obviously, if you're new to Bifrost, this might make not too much sense. But basically, I can tell because we have a face component, we have vertex, we have UVs, and then the normal and the position. Now, if I look at the other object, obviously the strand, and you can see that I have a strand component, positions as well, ratio, which is just a value of the strand from 0 to 1. In order to see, this is called curve view. It's just a basically 0 to 1 property on the strand, which is useful for other things. So this is like a more detailed view, as I was saying. And if you want to actually open this, you can open this and start looking at the data. And now you have the per point data basically. So we have around 4,000 and plus elements in this array. Or you can also say points, right? So, and then you can see the positions from this mesh. You can see the normals, you can see the UVs, and the UVs is a float too. You can see the offset of this face, the vertex data, and so on and so forth. The strand is going to be again a little bit different. We have the curve view, the ratio here, the tangent, which is a vector 3 because we're computing that, right? And you can turn off this, by the way, if you wanna compute the tangent here and all that. But that is what the properties that we have. So I always usually have this dock here because actually having the data browser is actually useful. One thing also that is nice here, because having opened this, and when you have a heavy simulation or heavy data set, this is going to be kind of computing. You can pause the data and then just say compute the data once. And right now it's actually difficult to see because I'm not really computing anything. But you can update the data just on the frame that you want to see. Anyway, so yeah, that is the way that you can bring anything. So let's say, for example, very quickly, if I wanted to add this, now I can add this guy here. Now we have 3 elements. Now, however, if you try to preview this, it's still showing 2. It's because this there is a bug, or actually, I don't know if it's a bug, but hopefully this gets fixed. But in order for this to load again, what you can do is just delete and reload again. This is gonna disconnect, but now when you preview this, you have now 3 elements because we have 3 elements, right? There's also a different way, like a little script that you can run to actually force this port to update without disconnecting and doing what I'm doing here, but I'm just showing you the manual way basically that's doing that. Now that is bringing everything here, which is fine, but let's say that I just want to grab the first item of this array. So there's a few ways. You have the get from array, which is most basically the way that everybody uses. So with this, and actually let me turn off this, we are grabbing the first item of this array, which is actually the coin. Then if I go to a second, it's going to be the cube, and then it's going to be the strand. You can see now that I can pick which actually index I want to bring here, right, from this array. And you can see also the change of ports. We went from an array to a single value. This line that you will see in many nodes mean that it's an auto port. That means that this can work on basically, you can also see in the array, you see that it has like a little line. This get from array that you will see later can be used with floats, vectors, and so on. Anyway, so yeah, this is a way that you can just pick whichever item you want to pick from this array. You also have the first in array and last in array, which you can see that can be useful if you always want to grab just the coin, for example, right, instead of doing the get from array, or if you want to grab the last, which in this case will be the strand, right? There's other ways too. You can remove objects from this array and all that. So, but I'm not gonna go into that. But yeah, so that is one way. So, all right. So let me actually just kill this cube because I don't need it. And basically that is what I did here. So if we look now at here, we have both objects. And let me just delete that too. Okay, so we have the 2 objects here, and basically, in reality, I don't need this, but I just wanted to showcase this node. It's a new node that came out maybe like like a version or 2 ago. I can't quite remember, but actually in this case, it doesn't really make sense since just we have 1 strand and 1 mesh. But you can see how useful this can be for other operations. Like let's say that you have a big array with a bunch of meshes and then also points, point clouds and strands or different splines or volumes or whatever. This can filter all the points, all the strands, meshes, and so on, and then you can just use that get from array or just bring everything into with a merge geometry, for example, right? All the meshes into one. So actually this is super useful, and I just wanted to showcase it. In this case, again, it doesn't make sense because I can just go from here and skip completely this node. And since we have just one strand and one mesh, I'm using the same index in this case for the strand and from the geo. All right, I'm gonna leave it on. So in here again, in this stream, we have the geo, and in this stream, we have the strand. And really, the strand is the hero here because this is what we need in order to create this effect. What I'm doing here is actually creating I'm computing the basis of this strand, and basically what that base is just computing these vectors, which are going to be very useful. So if we look at this, and we look at the diagnostics here, you can see that this is computing the tangent, the normal, and the binormal of the spline. And these vectors are very useful to create, for example, an orientation that then you can use on the create instance node, for example. So, for example, when you instance something in a strand, these are oriented the way that you want. And a quick way, for example, to do that will be using the normal to tangent to orientation. So you can then hook up the tangent and the normal, and this is going to give you a quaternion where you can then set up the point orientation. And the point orientation is a known Bifrost attribute that if you hook up that, if you set up that up in the instance, it's going to read that and it's going to know, oh, we have an orientation, let's compute it. You can also do the same with the vector between, rotation between vectors, right? And this is also another one that can compute a quaternion, or actually create a quaternion from this. In this case, we have the tangent, which is actually the blue vector, is the one that we're going to use for this. The normal is going to be the green vector that you see. Actually, it's like an up vector in this case, and this is strand. And then we have the binormal, which is the red vector that you see coming out. So I'm computing that. And what we need to do here, let me explain real quick, is basically to create this effect, I need to actually grab a point and then just move it along this strand. I could easily create this manually with the ratio and then also the point U of this strand, and then the point count of the points on this strand. But there's a few already good compounds that they do this, so I'm not trying to reinvent the wheel on here. The Val compound, and you should definitely download his library. It's super useful. You also have the Scatter Plus, which actually adds quite a bit more functionality than the normal scatter. Obviously, it's part of this. It's part of his library, so I will highly recommend downloading this. And then also there's another one that you can find in Discord as well. It's called Motion Pad, which basically does the same thing. So I'm grabbing a point. Right, there is a point, and let me make it red, why not, and make it a little bit bigger. And I'm gonna slow down this quite a bit so it makes sense. So we have a point, and then basically if I press play now, you can see that this is moving along the strand, and this is exactly what we want. Now, more importantly, well, you can put more points here, by the way. So again, play with this tool, but I just need one point going around. And this is actually the duration of the loop, so it's gonna loop every 30 frames. But more importantly is passing this point tangent here, or sampling or transferring, right? From, and remember that the tangent is this blue vector that we see here. So if we wanted to see this in action, I can do the point scope, enable arrows. By default, it's looking for point velocity. However, we don't have, as you know, we have just position and tangent. So I'm gonna say, give me the tangent, show me the tangent of this attribute, subtangent. And as soon as I do that, you can see that we see the point going around with the tangent vector here. And that is exactly what we need. And this is the vector that we're going to use to compute an orientation from this point. If I go here, and this is a node that's going to help us to create, or actually to compute an orientation. Let me bypass this real quick here. I'll show you this a little bit later. So the rotate points, this is gonna create a point orientation where you feed into this. So if I do rotate, if I do rotate points, you can see that that is the node, and you can see that the axis is a vector, it's expecting a vector. But again, we have this kind of line here, meaning that you can actually change the port to a string if you want to type the property or the attribute, right? And that's what I did here. But But this, you need to just give it an axis, and the axis that we want to use for this orientation is the tangent. So that's what I'm feeding into the axis here. By the way, this doesn't need to be normalized. You can actually check this because they're doing it under the hood. There's other ways to compute the same way, and actually you can go inside the node and see how they're actually computing the orientation, or to give you a quaternion basically. And this the radiance is just going to be our angle. In this case, you won't be able to see what I'm doing here, but it's basically just the angle that where the coin is, right? Where you want to be rotating to from. I'm using degrees to radians because obviously for us humans this makes more sense to work in degrees than radians, right? But and yeah, so and this is going to give us an orientation. So if I preview here, we have position and tangent. Even now, if I go here, we can have another new attribute, which is the orientation. And this orientation is what we need in order to create a 4x4 matrix to basically move, or actually rotate around this position. And there is a node in Bifrost that is called rotation around position to matrix. So if I drop it now, you can see that this expects a quaternion, an orientation basically, and a position. So we can have now, we have the orientation and we have the position. So we feed that into this node here. And since I know that we have just 1 point, right, because we can see the count, it's just one element, we can just grab the first in array and hook up this into here. And with that said, basically, that's going to give us, and you can see here, a float by 4x4 transform. And if we look our coin here, there is no animation, but as soon as we transform, right, this guy here, let me hide that. Now we have our old coin here going around the point. Very cool. So there you go. I mean, basically that's it. That is the fact here. I mean, as you saw, that's super straightforward and easy to make. Now, obviously, I did a little bit more because this coin goes down. You obviously now, for example, you can go and animate this by hand, right? You can go from 60 to 0, and you can promote this attribute, or this parameter, I'm sorry, to the top level, and then keyframe it and go to the graph editor and play with the curves and all that. But hey, we're in Bifrost, so why not do it procedurally? So that's exactly what I did. So let me actually speed up this a little bit. And if I now press play, oops, and if we look at we don't leave the angle at 0, and we press play, we're gonna do that. And actually, this is actually super easy also. So what I did here is grabbed the frame, I subtracted my start frame, and this is the timeline info node, which basically can give you the procedurally, like the start frame, whatever your start frame is going to be, the end frame, which in this case is going to be 1190, the mean frame, which in this case also 1001, but if you change this, it's going to change automatically, as you can see here, right? And the max frame, which is 1072 in this case. I'm sorry, yes, 1072, and then the frame step, which is obviously 1. Right? So I need to do this in order to then, when you want to do different operations like multiplications, addition, subtraction, whatever, you don't want to be dealing with 1001 and stuff like this, because this is going to make it a lot difficult to actually do these operations. So that's why I need to do this, because my timeline starts at 1001. Now, if your timeline starts at frame 1, then yeah, forget about this. You can actually bypass this and then just go directly here. But this is second nature to me because I always start my timeline to 1001. So I always have to do this in order for me to do some operations. Then I'm multiplying the value from here, from the frame, by another value, by a smaller value. And that basically, this is kind of like the speed of this. So if we look at this, you can see that we have started 0, and then the increment is going to be way smaller than going 1, 2, 3, 4, 5, 6, 7, 8, right? So this is basically controlling the speed of what I'm seeing here. Now, I don't want a value to go from 0 to whatever. I need a value that starts from 1 and goes down. So the easy way to do that again is just actually subtracting this value by 1. And if I do that and we look at this, now we have a value of 1, and then it's going to go decreasing basically the value. And you can see that it goes into negatives, and that is why I have this clamp from 0 to 1. So it doesn't go over 1 and it doesn't go lower than 0. Why is that, you will ask? Well, if we bypass this, right, and you can go easily, because again, this is procedural, it's not like a simulation, it's not colliding with anything. You don't want to go into negative values here, right? Or actually over or something like that. So that's why I have this clamp. And obviously, since then we multiply whatever value we get here from this, from the angle, obviously that's going to go back to 0. So we are kind of animating this procedurally. So we're going to see this in radians, but you get the point. So if I go back now, it's going to go to 0 and it's going to stop there. And that's it, guys. And we can control again the speed here. We can go a little bit faster on the rotation, right? We can slow down basically the whole animation here, or go faster too, you know. So actually I use less frames, for example. So you have full control over what you want to do here. You can create a compound here and promote all this stuff, and yeah, play with it. And yeah, I mean, that's it, guys. And as I said before, this is with an asset that's coming from Maya, creating the curve, and the base is basically the same, but I'll show you that right now. If I go to the base, spin setup here, and let me actually hide this and unhide the spin setup here and do a terminal. Let me go inside. The only difference here really is that you can see if I press play, there is nothing happening. Is that the base, I didn't create this edge or this curve spline in Maya. I created inside Bifrost, just to show you a different way that you can do this. So I'll run this very quickly. The rest, you're gonna see that it's actually the same. I can delete that because I don't know why that node is there. So basically I'm grabbing the mesh, and then we have these tag nodes, and then I might do a video about tags because I feel like people don't know them that well. I mentioned this at the beginning, but tags basically can come from Maya, or you can create it procedurally in Bifrost. And I prefer to work with tags over sets. Actually, Bifrost can read these create sets as well of components. But the advantage of component tag is that it carries with the object itself. So let's say that you export this, that is going to be inside the object. It's not going to be in the DAG, right? When you do a set, for example, it creates this value here. It's not with the object itself. So I prefer to work with tags over over sets. It's a lot more procedural, and you can create. If we look at the nodes here real quick, and I just type tags, you can see that we have a bunch of different tags here to create procedural selections, basically, of components. It's like groups. So in this case, I'm using the tag by threshold, and then this is expecting a property, but you need to feed a float property. And basically what I'm doing is grabbing the point position. If I just drop a new one here again, tag by threshold, you will see that the green port, the dark green port, is a float, and again it has that line, which means that you can hook up different things, right? In this case, I changed this to a string because I prefer to type, but you can also just basically get point position, right, and then do like a vector to scalar, right, and then grab whatever axis you want to use. But instead, it's a lot cleaner for me. It's just to type the property that I want to use. So I'm just saying position. So I'm basically what I'm saying here is grab the point position. Let me hide actually this. Grab the point position, the y-axis of this element or this object, and then basically what I'm saying, if this point position is less or equal to the max, which in this case is 0, then actually make a group. And as you can see, if I show you the D, which is diagnostics, is grouping the points at the bottom here, right? Obviously, if you change this, you can actually group more points depending where the threshold is of this property. You can pick obviously other axes here as well and all that. Obviously this works because the object is at the bottom, right? The bottom is actually at 0, 0 and it's right on top of this grid. If the object was in a different position, probably I would use a different property or a different tag method to tag this point. But since it's there and there's no animation, I mean, this is just easy. I'm giving a tag name, which is just the name of the property or the group. Just saying bottom. So if we check that, we can see that this is actually a Boolean data, an array of Booleans, and is basically from 0 to 1. So whatever is 1 is going to be the points that we have selected here, right? And the rest is 0, 0. Now you can see that these points have an ID, whatever they are the ones here. So I want to get the IDs of this selection. And in Bifrost we have this find all true in array, which is going to grab this array, it's going to check the array, and it's going to find all the values that are 1, true in this case, right? And it's going to give us the indices. So if we look at this data now in a new data browser, or actually here, now we have, instead of the 0 to 1 values, we have the IDs of they are just ones, and you can see. And I can check this. So let's say open a new data browser, and I can just filter this, for example. So I can say any value that is greater than 0, give it to me, and you can see that we have 80 points selected in both in the indices, right? And then also on the values that are above 1. And you can check too that they match actually this is 1 and that is the ID, and you can see now that we have the IDs that are matching the same. All right. So then in the get from array, you see now we are actually, this get from array can work in objects, and now I'm actually make it work on a vector. So I'm grabbing the position from this object, and I'm saying, okay, I want to grab the positions, but I want to just grab these indices, the indices that we pick in this at the bottom right here, and then giving the positions from this. So basically, if we look at this now, again, it's 80 points, and then we see the positions per point of this array that we picked. And then finally, we just say, okay, we have the positions now, and I can just feed these positions into the construct strands, and that is going to give us the strand procedurally here. So now if we look at this, and let me hide this, we have a strand there, as you see. And the rest is the same, updating the basis of this, and moving the point along the normals, and yada yada yada, doing the same thing. And if we look now this outside, we have the base rotating the same way as the coin. Now obviously it's a little bit lower speed, and then also the angle that I have here is a lot lower, because obviously I mean, you can play it. I can go 60 on this, right? It doesn't really matter. And you can do this crazy stuff, but obviously since this is a bigger object, probably at this angle this will break. So I just play, I don't know, I play with this at 14. And that's it, guys. As I said at the beginning, this is the USD stage, and it's very simple. Just getting a prim and all that, and just to a nice preview in the viewport. So with that said, basically, yeah, I mean, there's not much to it. Now you can just have fun and play with this setup, and then, you know, you can use it, as I said before, for a base, for a glass, whatever you want, and it's gonna be just working. Hopefully this was useful. If you have any question, please let me know. I'll share a file. No, the exam, I'm gonna share actually a file, but it's not gonna be with these assets, but it's gonna do the same. With that said, until next time, guys, cheers.